Hi, this is Jim.
And Ralph.
And we welcome you to Psychology Takeaway, the podcast that takes a look at recent events and recent literature in the field of psychology. And, Ralph, we try to make sense out of it for ourselves
and for our listeners' lives. And today I'm happy to report that we have two special guests, both of whom are in one of Jim's classes. And I'm going to let Jim introduce our audience to the two ladies who are here.
Thanks, Ralph. We have Kristin Cooper. Hi, Kristin.
Hi.
And Mia Dante.
Hi. Hi.
Hi. Let's see, Dante, like as in the Inferno, right?
Yes.
Okay. Well.
Like the 7 rings of hell. Dante's Inferno.
Okay.
Yep.
Yeah, I think I'll change places with you, Ralph. You know, we get our information for our podcasts in a lot of different places. And a while ago, I was listening to Science Friday, and they were talking about glia cells. Well, everybody knows that glia cells are these boring little cells that, hold neurons together. They were called glia, which means glue. But the presenter was saying, hey, we know a little bit more about glia cells than they did 100 years ago. And so in class yesterday, I asked if you two would come on in and talk about these nifty little cells. Okay, glia. So, Mia, glia. Why don't you start?
I was going to say, glial cells are actually kind of interesting because they split glial cells up into 2 different categories. They split them into microglia or macroglia.
Mm-hmm.
So macroglia are the larger cells of the 2, and they make up the bulk of the glial cells that we have in our central and peripheral nervous system. And the types of macroglial cells, they have astrocytes, they have oligodendrocytes, and then Schwann cells, which are in the peripheral nervous system.
Okay. And we've got some, if these sound kind of esoteric, we have some pictures up under Learn More. You can go down and take a look at these various cells. They look kind of cute.
I was going to say, they look really pretty under a microscope.
Mm-hmm. Yeah. Okay, so we've got these various kinds, and about half of the cells, neural cells in our body are neurons, but about half of them are glial cells, right?
Yep.
Okay.
So, Mia, let me interrupt you with the dumb question of the day. Do all vertebrates have glial cells?
Yes. Yes,
So,
they would.
My dog has glial cells.
Yes.
My cats have glial cells.
Yes.
Okay.
And that's also how they have, the ability to learn, is from the glial cells assisting the neurons that helps with learning.
Okay.
Probably your fish have glial cells, Ralph.
That could be, although the fish I catch, I think, are all the dumb ones. So maybe they don't.
I do know you can teach a goldfish how to jump through a hoop.
Mm-hmm.
Okay.
Yeah. They used to use goldfish at Alma College, just down the street here in their learning lab. The rats were too expensive. Kristin, what is your spin on the glial cell?
I've spent a lot of time looking at microglia under a microscope, and as Mia said, they are very pretty.
Yeah, they look net-like, don't they?
Yeah, yeah, and when we stain them, they're different colors in the microscope too.
Uh-huh.
So, talking about learning, the ways they work with learning would be through long-term potentiation and long-term depression, and that's not depression as in mood; it's depression as in almost suppression.
Slowing down.
Yeah. So when you have different neural connections, the glia can either enhance and strengthen that connection, the different pathways, or it can depress it or suppress it, or even the microglia will come in and eat little old dead
It's sort of the janitor.
Yeah. Clean up, and it also works with immune function. And so we had talked a little bit earlier about that they have a role in neurodegenerative diseases such as Alzheimer's and Parkinson's.
Mm-hmm.
And so sometimes
So what? Say more about that. What would that role be like?
Yeah, so one of the things we're looking at is that there are a couple different phenotypes of microglia, and one is what's the word? Inflammation and like pro-inflammatory, and the other one is like anti-inflammatory. And so they can have good effects, they can also have bad effects. So if you have a lot of the pro-inflammatory microglia, that could either A, indicate that there's a lot of immune reaction happening. That could also indicate that the microglia are dysfunctioning and creating an inflammatory response.
Okay.
But they could also be the anti-inflammatory, and they could be going and cleaning up and fixing things. So that's kind of a lot of what I look at. And
you mentioned inflammatory.
Yeah.
We've been hearing much more about that in health these days. Like a lot of the diseases that we thought of in the past were just sort of, you get a flu, you get a cold, you get arthritis. They all tend to now be traced to inflammatory conditions.
Yeah.
So you're saying that these cute little glia could maybe even at some point in time, like little Pac-Man, go in and okay.
Yeah. Specifically the microglia, astrocytes as well, but they tend to do more of like the long-term potentiation, or like giving the neurons things that they need to make the connections they need and to fire the way they need to.
Yeah. I don't know, this is a sort of a speculative question, but why do you think we've ignored the glia for so long? Yeah,
honestly, I think that part of it could have come from the lack of technology, for one. Because all of this, like the microscope technology that we have, the electron scanning microscopes, those pictures that give us a better idea of what these cells do, it allows us to see how they act and how they function. That's why recently we've just now kind of been getting more of an idea of what they do and how they play into these different diseases and disorders.
That's a good point. When I was taking biology, I'd look through a microscope and I could maybe see an amoeba there. I mean, these cells are tiny, right? I mean, tiny, tiny, tiny. And so we just didn't have that technology.
Yeah, as we were talking, glia means glue in Greek, and that's because originally when we found these cells, we thought that their only function was to provide structural support of the neurons. So we had no idea all of the things they do, and like as we're learning, they do even more. Even the same type of glial cell does more than we knew.
Go ahead, Ralph.
Well, here's a question then that again maybe totally off the wall, but we've had a lot of press in the last couple of years about concussions and the impact of concussions. So is it possible that what is damaged in concussion is some function of the glial cells?
Yeah, and we're actually learning that like traumatic brain injuries might behave very similarly to neurodegenerative diseases and progress over time almost pathologically.
Yeah. We're going to have Sheila on in a couple of weeks, and she has kind of a specialty with the tau protein, which goes along with concussions.
Yeah.
But so I'm thinking, if there was some, well, I'll ask the question: is there some way to enhance glial cell functioning?
Maybe. That's something we're looking into, and there's all the ways they interact with the different systems, like the endocannabinoid system, which is like our internal system that would work with like cannabinoids, but also the ones that we make naturally through our body is one thing we're looking at. Cannabinoids,
as in cannabis?
Yes, but we have them in our own. We make them ourselves.
We make them ourselves?
Not the same thing that you would get in like
at whatever 17 shots.
Yeah, not the same thing. Yeah. But that's the system that interacts with it. So that interacts with some of the glial cells.
Okay, well, I understand that cannabis has kind of a relaxing quality. So you're saying that that's what they could be doing too?
it's working on that system.
Okay.
Yeah.
So
and Mia works with like tau proteins, as you were saying too, because tau proteins is we actually, Mia and I both work in not in the same lab, but like right next to each other. Yeah, a lab. Our advisors share a lab, so we both study neurodegenerative diseases, and tau is involved in all of that too.
Well, that's a big area here in the psychology department, neuropsych people. Dr. Dunbar, who's been on the podcast before, has been, he's interested in Huntington's, Parkinson's, and Alzheimer's, right? Yeah. And hey, are we getting any closer in any of those for cures? Oh, so you're smiling, but that's okay. We won't quote you, and we'll keep this under wraps.
I was going to say, when it comes to the cure of these neurodegenerative diseases, and I'd like to put cure in little air quotes, majority of the treatments that like big pharma companies come out with, for example, Pfizer came out with a treatment for Alzheimer's. It doesn't stop the progression. How big pharma companies have been kind of aiming to kind of slow the issues of neurodegenerative diseases is they focus on controlling the symptoms versus actually changing the brain and the processes that are being affected by these diseases.
Okay, so these Alzheimer's drugs are not up there cleaning out plaque or anything like that.
Correct, yeah.
Well, maybe we should get the Glia to go up there, like her little Pac-Man.
That's what microglia do. Yeah, but then the question is, so are those microglia enhancing inflammation when they do that? Is there there are the drugs that go up in and clean out the plaques, but we're not seeing any cognitive benefits from those drugs or clinical benefits. So we know that people with Alzheimer's or other neurodegenerative diseases have a lot of plaques in their brain. But even when you take those plaques out, they're still having symptoms. And so is it the process of the plaques being formed on the brain? Is it the process of the microglia kind of overreacting to all these plaques? What's happening?
Well, I know about...
So you could say, as the rapper might, you can clean out the plaque, but there's no going back.
So far, yeah.
So far.
Yeah, that's a good song. You should record that for the podcast. Maybe the intro.
Yeah, okay.
Well, I have to tell our listeners and you guys that in university you get academics teaching, you get research, and you get service. And my service has always been not singing in public.
It's good for the psyche, for the glia.
Yeah, so we don't have anything that reverses the damage, say, of Alzheimer's. But we do know that there's some plasticity in the brain, plasticity and neurons. And so if we could clean things out and in some way enhance neuroplasticity, would we be going in the right direction?
I would like to think, and kind of going off of your neuroplasticity point, one of the glial cells that's extremely important for that is called an oligodendrocyte. It forms the myelin around neurons, which propagates those electrical signals, so that the degeneration of those would kind of lead to those deficits.
That myelin sheath, that's kind of a gelatinous thing.
Yes.
Gelatinous thing. Yeah. Okay, and that's a protective thing for the neuron.
Yep.
And the glia cell helps that along, right?
Yeah.
Okay.
And
it forms it.
Yeah, I feel like if maybe one day there would be a treatment to strengthen your myelin, I feel like that would even help a little bit more. I don't know if that's been something that's been done yet, but I know that it's kind of been a larger focus in neurodegenerative research.
Okay. Now, you mentioned big pharma. Well, right now you're at a university, a PhD granting university, doing research, but probably you're not going to stay here for the rest of your life. only a few people who are lucky stay at the university for the rest of their life, like Baber here and myself. The rest of you have to go out and get a job.
Yeah.
We do? What? Really? No one told me that.
Well, it's obvious that you have a real interest in research.
Mhm.
We talk to a lot of students who say, research, yeah, I don't like that at all. Ralph and I do. So what are you thinking of for your career? And because 5 years from now, 10 years from now, you're still going to be looking at neurons and glia.
Mhm.
And
Probably.
and hopefully you've moved on. So
Yeah.
here's the $1 million question, as Ira Flynn would say. If you had $1 million or had all the money in the world, how would you spend it to do research?
Good question.
I mean, besides taking Ralph and I out to lunch as consultants.
Oh yeah, that would be the least we could do.
It's almost, there's like so much we don't know and so many possibilities. That's like an overwhelming question.
Okay.
There's
Well, just think of one. Which
Oh,
one little
geez.
thing.
I was gonna say it would definitely be easier if we kind of knew a little bit more about the mechanics, but I think I would use the money to do more research on those mechanics.
Okay.
So we would hopefully be able to get to the point where we would actually have treatments
Mhm.
that might halt the disease, if not completely reverse it.
Okay, here's a self-serving kind of question. Okay, you've got all the money in the world. Are you going to throw it back into, say, a university and fund research at the university level? Where do you get the biggest bang for the buck? At the big pharma and Pfizer, or at a place like CMU or University of Michigan?
It's interesting because you do have a little bit more freedom at the university level on the things you research and the directions you want to go. Where with those larger pharma companies, like, yes, the universities still rely on grants and funding from companies like the NIH,
Mm-hmm.
but big pharma companies, that's their only source of grant money. So they have to appease the higher up company, where at universities you have that little bit more freedom. So
Mhm.
honestly, I think I would kind of divvy it up
Uh-huh.
if I had all that money, just to kind of play the entire field and
Okay.
get the most bang for my buck.
Mm-hmm. Okay.
Mhm.
So you'd fund some graduate students, and the thing about big pharma is that they're motivated to do something, but they're motivated to work quickly for cash, right? I mean, whereas I'd like to think at the university level we're a little bit more idealistically oriented.
Yeah, definitely.
Right, Ralph? We like to think that.
We'd like to think that,
Whether-
whether it's true or not. But, so, let me ask you then, what are you currently doing? And if you could project, let's just say you're going to stay here for another 3 years. Knowing what you know now, what direction would your research take you in the next 3 years?
Kristen, do you want to start?
I can start. I'll probably be here a couple more years. We actually just ordered mice for my project, for my PhD project. And so I mentioned the endocannabinoid system. That's what I will be looking at for my thesis. So basically, we're gonna look at general aging to start, and we're gonna have some older mice and simulate chronic cannabis use.
Okay.
And there are some kind of normal aging processes that happen in the hippocampus, which is the area I will be looking at in the brain. And so we want to see if that simulation of chronic cannabis use affects that normal aging process, if it makes it worse, if it makes it better, what happens. And so that's where I'm going right now.
Okay.
So worse in the sense of speeding up aging,
Potentially. Or cognitive. So we'll be doing testing. We'll be doing behavioral testing on the mice, and so including things like memory and like maze testing, and then we'll also be looking at more cellular results and things under the
Okay.
microscope and blood analysis of we'll be looking at maybe glia, maybe how many astrocytes or microglia there are that could be signatures of what's going on.
That's interesting, because that was one of my PhD dissertation thoughts, ideas, but never got off the ground because of the difficulty in getting THC, and using it on mice.
Yeah.
Then I came from Rutgers to Central Michigan. I turned on the TV one day, and in a high school up in Gladwin, I think it was, or Gaylord, they had a teacher who had some mice in an aquarium, and the teacher was puffing, not inhaling, blowing in to see the effects on the mice.
Funny. That's so funny. We're gonna vape pen and tube it into a box with the mouse in it. A little better than maybe blowing at them. Hopefully less stressful for the mouse.
And don't inhale.
Yeah, exactly. I don't have to worry about that. It is, a little difficult to get still, but probably better now that it's legal in Michigan.
Well, here's a story that actually has nothing to do with Glia, but
Here we go again.
I saw a thing today. The worldwide average age of death is 86 years. Okay, that includes places like Japan, which has a lot of people who are older than 100, and places where people die still in their 40s. Mm-hmm. So average 86 years. 7.7 million people die early because of tobacco smoking. Mm-hmm. Mm-hmm. So, it's an easy thing to control. Mm-hmm. I mean, for somebody who's addicted to tobacco, it may be not an easy thing.
It's a very difficult addiction.
Yeah. Mm-hmm. But it is something that you can control when you're 14 by saying, I don't start. Mm-hmm. So I thought, what do we know about the potential for people living longer than, let's say, 86 years? Well, one of the things that we probably could find out is something maybe to do with glial cells. Because maybe if we get them in the proper alignment of the stars, as it were, they could say, yeah, I can help you live 10 years longer. Mm-hmm.
Okay.
It'd be nice to find out.
Yeah. And Mia, what about you for 3 years down the road?
I likely will not be here, but currently my research is building off of previous master's students. We look at similar aspects of Alzheimer's, but my project this year, we're taking a little bit closer look at those oligodendrocytes that I talked about earlier, because there is a lot of focus on the microglia and the astrocytes. And there has been research done about oligodendrocytes in diseases like Alzheimer's. It's just that there's less of it. So what I'm doing for my project is I'm looking at all 3 of our Alzheimer's model animals that we use. And I'm going to be counting the number of tau positive cells. And after I count those, we're going to go through, stain them, try to verify that they're oligodendrocytes to show that there is tau proteins in these cells, which means it would eventually cause death of those oligodendrocytes, leading to demyelination and leading to that neurodegeneration.
Okay. So the bottom line here is trying to find something that gets rid of the tau protein, right?
That's a big thing that people in the Alzheimer's community look at. It's a large driving force believed to contribute to Alzheimer's, yes.
Yeah. You were at the Student Research and Creative Endeavors Conference a couple of weeks ago, and I don't know if you got over to the far side of the building. They had some folks there who were doing work with tau protein too. Did you get to see them?
Yes, and I actually work with them, or I see them around our lab quite a lot since we're over in the neuroscience area.
It's not a very big area, spatially.
But do you think maybe in the future cooperation between various disciplines is going to have to happen?
Yeah, I feel like that would be a crucial thing. It's been a big conversation in our class that over the years, the kind of issue that we haven't been able to make as many strides as we would like is due to the lack of cooperation and collaboration between different specialties. Because I truly believe that every specialty has information to bring to the table. And if we all came together, I really feel like that would drive us forward.
Yeah, that was going to be actually my next question was what are the biochemists doing? You know,
I was going to say, they take a little bit different of a look than we do from the neuro approach. They look at the specific pathways. Like there's the cyclic AMP pathway that's involved in different neural processes. So collaboration, even with them, has been limited, but it would be extremely helpful and useful.
Yeah.
Yeah.
Well, we've been talking today with Kristin and Mia and Ralph, of course, and this is an interesting area. It feels like we're kind of like explorers in a brave new world. And so at some point, we'd like to have you on back, and so you could talk about the recent developments. In fact, in your field, recent developments could happen within a day or so, right?
Yeah.
Absolutely.
That's the exciting thing, though, is every day things are changing.
And it's really great to see scientists excited.
Yes.
Okay. So, Ralph, this is Jim
And Ralph,
saying, keep your stick on the ice
because we're all in this
together.